Okay. I hope y'all can hear me. Oh shit. Sorry. Give me a second. Oh shit. Sorry. Okay, so. Alright. Let me, go over here. Give me 1 second, y'all. I'm gonna, hopefully y'all can hear me well. Hold on guys, I'm gonna do something very quickly. Give me a second, guys. Oops. 1 second. Give me a second, everybody. Hold on. Hope I can, not sure if I can. Oh, here it is. Here it is. What I'm gonna do is. Okay, so, today, I know I don't really go live on this channel, but, you know, I want to go over some problems. Let me, and actually, hold on, guys. I'm gonna put, give me a second. If I go over here, hold on. I just want to go ahead and put this over here if I can. 1 second, guys. Okay. Hopefully y'all can hear me. Now, hi. I'm glad you joined. Let me, okay, perfect. Now, what I'm gonna do is we're gonna go over, composite figures or composite shapes. So, let's see here. We're gonna look at the problems. We're gonna look at some problems. Let's see. Where are they? Alright, so this is, and y'all let me know if it's playing well. I hope it is. Give me a second. a second. Okay. Alright. Hopefully it's playing well. Sorry. I'm like trying to, make sure that the stream is going well and it's smooth and there's no problems with the stream. And y'all can let me know if there's any issues. Sorry, I'm just like making sure everything. I should probably get like a moderator. Know if there's any issues. Now, so let's look at the problems. Number one, here's what I'm gonna do. So, so number one, right? We're gonna look at this problem here. So let's see. It says to find the area of each composite figure. So find the area. It's composite slash compound figures. So just letting y'all know. Now the first question of each composite slash compound figure. Okay. So here we have the first question, and I'm just gonna like draw it out. Let me see here. So it kind of looks like, okay, so I'm just gonna do my very best to draw it out. Do it this way. And it's not gonna be drawn to scale, guys, obviously. Sorry, hold on. I don't know why it's doing that. So it's not going to be drawn to scale, obviously. I'm not gonna... It's not going to be drawn to scale, but the main thing is that we just make sure that it's just, you know, as best as possible. There's this part, and then there's, obviously there's the I guess the square part, right? So there's this part and the square part. Let me see okay. So it doesn't really show us a, what is it? Now, it doesn't show us the shapes that are involved. Obviously, though, we can kind of see what shapes are involved in this. And like I said, this is not drawn to scale, so yeah. But we can see the shapes that are involved here. I feel like I made it too big, but it doesn't matter. So what we're gonna do here is we're gonna go ahead and actually, I don't know why it keeps doing that. We're gonna go ahead and find the area. Now, what they're telling us here is that they're telling us a few things here. They're saying that number one, the area of, or I'm sorry, the side length. So this side length is 6 centimeters. And then what they're saying is that this side length here, so this side length here is 5 centimeters, right? And then they're saying that that this side length over here and actually this line, I mean, we'll see if we need that, but they're saying this side here is what is it, 3 centimeters. So like I said, it's not drawn to scale, but we can just, you know, make do with what we have, right? So here we're gonna go ahead and we're just gonna, oops, sorry. We're gonna go ahead and we're just going to find the area. Now, if you look very carefully, guys, this is one part, okay? You can create 2 different shapes out of this, okay? And we want to make sure we understand that you can create 2 different shapes, excuse me, out of this. Now, the way this is gonna go is we're gonna go ahead and we know that sorry, hold on. Oh, and this, I'm sorry, this is supposed to be 3 centimeters. I'm so sorry, guys. Hold on. That's supposed to be 3 centimeters. So we know that we have 2 different things. We have a triangle, and like I said, I'm not going to draw it to, it's not going to be drawn to scale. But we have a triangle that has, we know that they're saying that this, like this, basically that side there, right, from here to here, they're saying this is 3 centimeters, meaning that the height of this triangle is 3 centimeters, okay? So we want to make sure that we know that, okay? Now, so this is 3 centimeters, okay? And we can, so we can see here that, so that's the height. So therefore, we know that this is the height of the triangle. And they are saying that this part over here is 6, meaning that the base of the triangle is also 6 centimeters. So this base here is, this over here is 6 centimeters, okay? We want to make sure we understand that. So, let's see here. So here we can use the area of a triangle to find the area of this. So you want to remember that the area of a triangle is going to be the following. And I don't know why it's playing like that. Oh my god. I know it looks really choppy, guys. I'm sorry. I don't know why. Why does it do that? This is kind of why I don't really broadcast. Now, we can see here that the area of a triangle is area equals 1/2 base times height. Now the base is this part and the height is the green part. So we can see that this is the height and this is the base. So the base is 6 and the height is 3. Yeah, the base is 6, the height is 3. So we have 1/2 times 6 times 3, right? And we can see that this is 1/2 times 18, which equals 9, right? And actually, let me try to just, I'm gonna disconnect the monitor because I don't know if that's what's making it laggy. Now, hold on, guys. Okay. Now, here, we're gonna go ahead and, so we know that that's the area of the triangle, right? The area of this triangle is 9 centimeters squared, right? So that is what we get for that. So we know that it's 9 centimeters squared for this one. Now let's look at the area of the square, of the rectangle, or square, or something like that, right? We can see that the area of the rectangle, we have, or the square here, we have, the bottom is 6 and the side length is 5, so it's 6 centimeters here and 5 centimeters over here. So we know that the area of the rectangle, so area of a rectangle, aka a type of quadrilateral here, is gonna be area equals length times width, so, or base times height, right? So we can say that the length is 6 centimeters, the width is 5. So we can say that the area is equal to length times width, which is 6 times 5, which is 30 centimeters squared, right? The reason why we say it's centimeters squared, guys, is because length is 6 centimeters, width is 5 centimeters. So 6 centimeters times 5 centimeters is 30 centimeters squared. That's why it's squared, right? Now we know that the area of the rectangle is 30 centimeters squared. So therefore the area of the whole thing of the whole shape is area of triangle plus yeah, I think that was what was making it laggy, was the plus area of rectangle was the monitor. I don't know why when I plug in the monitor it makes it very laggy. I don't know why. Does that make sense to everybody though? Does that make sense to y'all? Let me know. Press 1 or press 1 in the chat if that makes sense. Press 2 if it doesn't. Or if you have questions, let me know. Now we know the area of the triangle is let's see. Okay, good. Perfect. Now we know the area of the triangle is 9 centimeters squared. So 9 centimeters squared plus, and then the other one was 30 centimeters squared. So the total area will be 39 centimeters squared. And that is the total area of this shape here. Okay. Now, let's go ahead and do the next one. Okay. So problem number 2 is a little bit, it's a little bit more, I mean, it kind of, it's not as bad. At least I don't think it is. So what they give us is, now of course there are some in this problem like number 3 that are harder. So I just want to, you know, emphasize that. Now, number 2, they're giving us 2 shapes, so it's kind of like, and of course, like I said, these are not drawn to scale, guys. It's something like that. Again, it's not drawn to scale, but we can, so we can kind of, oh god. Okay, hold on. Something like this, right? We can see here that there's, so here's 80, so this is 80 yards. This is 40 yards. Oops, dy, not dy. That's calculus. And then the top is 48 yards. So, I'm sorry, the side is 48 yards as well. Sorry. So this is 48 yards here. And then the top, the very top is also 48 yards. So this is not drawn to scale, guys. None of these are drawn to scale. I'm just letting y'all know. Now, let's see. We can clearly see there is something very, you know, we can clearly see something, very obvious here. So we have 2 different shapes, obviously. So you want to split it up into two different shapes. There's a square, and it has a side length of 48 yards. Now, the one thing you need to know about squares is that when it comes to a square, all the side lengths are equal. So they're all congruent, right? So therefore, this side length is congruent to this one, which is congruent to this one and this one. So the square on top of this, right? Let's draw like a little, like, kind of dashes here. And so what this means is the bottom is also 48 yards. Now, oh, I'm sorry. Let's not do that. The side is also 48 yards. So this side is 48 yards. Now, let's try and find, so really what this means is this is congruent to this, and actually let me make it smaller. Sorry guys, hold on. This is also 48 yards. Okay. So we know that the area, again, area of a square, if I know that these all have the same length, area is equal to b squared, really. It's the side length squared, really. So we know that again, it's gonna go this area. So area of the square. So area of composite shape is area of square plus area of rectangle. And we know that the area of the square is going to be 48 quantity squared. So area, if b is equal to 48, the area is 48 yards squared. And if I calculate that, oh gosh, where did I put my calculator? Crap. Well, we can always use Desmos. I can't find my calculator right now. Let's look in here. So the area of this is, it's gonna be, what is it? 2,304 yards squared. So, right? Yeah. So, we know that that is the area of the square. So the area of the square, I'm sorry, wait. Yeah, the area of the square is 2,304 yards squared. So we know that that is what this is. So 2,304 yards squared. And then it's going to go plus the area of the rectangle. Now the area of the rectangle, we can clearly see this one here. These are the side lengths, okay? So we can draw another, we can draw the triangle, the rectangle itself. And again, it's not drawn to scale, but the bottom is 80. So we know the bottom is 80 yards. And the, you sound, oh, thank you. I don't know if that was a compliment, but yeah. 40, and then the side here is 48 yards. So the area, so let this be the base, and let this be the height. So that's the height. So again, area of rectangle is base times height. And so this is 80 times 48. Sorry guys, hold on. Which is gonna be, what is it gonna be? 80 times 48 is 3,840 yards squared, right? Because they're both in yards. So we do yards squared. Now, that is the area of the rectangle. So this is the area of the rectangle. So now, let's plug that in. It was 3840, right? So 3840 yards squared. So that is this part, right? That is this part. So now adding those two together will give us the following. And I really do wonder where my calculator is. I cannot find it anywhere. But anyways. So 2,304 plus 3,840. So my total area is 6144 yards squared. And that is the total area of this one. Does that make sense? Press 1 if that makes sense. Did someone rob what? Oh no. No, someone didn't rob my... I can't find it because it's somewhere in here. I just cannot find it right now. I don't know, my room is a mess, so... I just can't find it at the moment. Is it? Oh, is it? Oh, it's right here. Found it. There we go. I found it, guys. Okay. I'm gonna use my calculator instead. Yeah, I found it. It was in my bin. Alright. Let's look at the next problem. So that is the total area. So press 1 if that makes sense. I think you said it did, right? Vanx_anime. Yeah, I think you said yes. Now, let's see. Now number 3 is a little harder, okay? I'm not sure why. Okay. For number 3, this is what I'm wondering. For number 3, we have 2 different things going on. So we have a half a circle. So number 3, there's like, okay, so I'm gonna try to draw a circle. And I'm gonna try to just draw this here. But I'm gonna try and just... something like this, right? And of course this is dashed, so it's kind of like, I guess it doesn't really matter, but it doesn't really matter, but if it's dashed or not, but here, and we know that there's a triangle that's kind of, it's like a right triangle. It's what it looks like. That is a really crappy drawing. Hold on. Hold on, guys. Oh my god. Sometimes I can be like a real perfectionist when it comes to these. I guess it really doesn't matter. I'll just... give me a second, y'all. And I don't know why the degrees went away. I guess. we'll just do it this way. Something like that. It's not drawn to scale. It is not drawn to scale. But we want to find the area, right? This is 27 feet here. And they're saying that now this is what I'm wondering. They're saying that this part is 9 feet. But what I wonder is, and actually I didn't draw it in the correct position. It's from here to here, apparently. Something like this. And because it meets in the middle right here, I am assuming that this is the radius. Okay? Because if you do a, let's say we do like a triangle here, I'm assuming, and I do think, that all of these sides of the triangle will be congruent, meaning that this will be an equilateral triangle inside of the half circle there. I'm just explaining why I believe it is the radius, in case y'all don't understand, because it looks like an equilateral triangle there. Now, let's see. Now, if we look at the, so this has to be the radius. But the thing is that we are talking about half a circle. Okay. So what I'm saying here is that let's pretend we have a circle here, and only this, we really only have this here. Is considered our half circle in the diagram. And what they're saying is that when it meets with the triangle in the middle at a certain angle, like that, let's just pretend that's what it is right there. It is literally equal to the radius. So this has to be the radius of the circle. And the entire thing here, this entire part, is the diameter, which is equal to the height of the triangle. So y'all can clearly see here that the diameter of the circle is the height of the triangle. Okay? Does that make sense to you guys? Does that make sense? Press 1 if it does, press 2 if it doesn't. And if it doesn't, let me know what your questions are. Because, yeah, I just want to make sure that makes sense. That the diameter is the height of the circle. I mean, is the height of the triangle. Because it meets in the middle. Okay, good. So, we have half a circle, so we're just gonna, really what I'm gonna do is, I'm just gonna do this, and I'm gonna just do this here. Okay, now, So this circle, as you can see, the radius has to be half the, I'm sorry, the radius is 9 feet. But we're talking about half a circle, so it's going to be 1/2 pi r squared h. I'm sorry, not h. 1/2 pi r squared. Okay, so that is the area of half the circle. Now, okay, so that is going to be the area. It's really pi r squared, but we're talking about half of it, so it's 1/2 pi r squared. 1/2 pi r squared, really. So this is going to go 1/2, and then it's going to be, it's going to go pi, okay, and then times, and then 9 squared. So it's going to be 81 pi over 2. I will go ahead and just approximate the pi once we add everything up. Okay. Now, the diameter is 2 times the radius. We want to remember that. The diameter is 2 times the radius because this is the radius, and then so this is another radius, so when you add them together, it equals the diameter, so it's 2 times the radius. Does that make sense? Remember that the diameter is 2 times the radius, right? Does that make sense to you guys? Press 1 if it does. Okay. Now, now here, we're going to go ahead and, let's see, we're going to go ahead and, so the diameter is 2 times, and it's going to be 9, which is 18, right? So the height of the triangle, really, the height of the right triangle, because it really is a right triangle, guys. It really is. So the height of this is, again, the diameter of the circle, which is 18. And the base, as they tell us right here, is 27. So this is 27. That is the base of the triangle. So it's 27 feet. Now remember that the area of a triangle, again, is 1/2 base times height. So let this be the base and let this be the height. So it's 1/2 times 18 feet times 27 feet. If we calculate that, it's 243 feet squared. Now, again, we know that the area of half the circle was 81 pi over 2. So the area of half the circle, and now remember that the total area is area of half circle plus area of triangle, or right triangle if you want to call it that. Now, so again, the area of half the circle was 81 pi over 2. So 81 pi over 2. And plus the area of the triangle, which was, excuse me, it was 243 feet squared. Let's approximate this expression. So if you can approximate the 81 pi over 2 as well, and then just add it to the 243. But we're just going to put this entire thing into the calculator and then see what it is. If y'all want to round to the nearest hundredth, this is approximately 370.23 feet squared. And then to the nearest tenth, I don't know if it said to round to the nearest hundredth or the nearest tenth. I don't think it said anything. Oh, round your answer to 1 decimal place. Okay. I see. Okay, I see. Okay, to the nearest tenth, really. So you want to do it to the nearest tenth. Forget the nearest hundredth. Okay. To the nearest tenth, which is 2 decimal places. Is going to be sorry, hold on. 370.23 approximately feet squared. So that is the area of this composite shape. Let me press 1 in the chat if that makes sense. If that all made sense to you guys. Or if you have any questions, let me know. Okay. Give me 1 second, guys. Hold on. Oh, give me a second. Okay, sorry guys. I had to put my my calculator to charge because it's low battery. Okay. Give me a second. Let's look at number 4. Now number 4 is the same idea. Let me think here. I'm pretty sure it doesn't matter if this triangle does not, like, it doesn't matter if the triangle itself is not, how do I say? For number 4, it doesn't matter if the triangle is not, like, drawn, it's like, I don't, it looks like scaling, or, not scaling, but, or yeah, scaling. It doesn't matter if it looks like like a scaling triangle. You can still use the same formula for the area of the triangle. It's always the same formula. here's what I'm gonna do. So let me see. The only reason why I'm putting lines, guys, is because I want to make sure that I'm drawing this correctly. Because, yeah, I don't want to... Hold on. Give me a second. So, it kind of looks... something like this, and then there's just a random no, just I'm gonna just do this now. Obviously this wouldn't be drawn in, but obviously we can tell that that is, you know, that is the base of the rectangle there. And then we're given that the height of this, so we're given that the height of the triangle that we're given is 5 meters. Just gonna take this off. So we're just given that, you know, we're given this, right? This is the height of that. And then we're given that the height of this is 3 meters. Now, of course, you wouldn't know that if it wasn't on graphing. I mean, if it was, you know, I'm just doing it on graphing paper so that I can get the shape as what is it, as accurate as I can. Because if I just draw it myself, it's going to be hard to see it if I don't draw it to scale. I'm just saying. And then the bottom is 8 meters. Now again, we want to... So, what we want to do is we want to draw this imaginary, like... You know, this imaginary line here, this kind of line here. Like I said, you always want to be able to split it into two different shapes, right? Sorry, hold on, guys. You want to be able to split it into two different shapes, excuse me. So, oops. So, what we're gonna do here, we're just gonna, let's see. We're gonna go ahead and grab the triangle. So really, what I want to do, and like I said, I'm gonna grab I'm gonna do my best to like get this part. It's not what I want to do. Okay, so let's just, I'm just gonna not draw it to scale, but basically, you have a triangle. Something like that, right? I know it's not drawn to scale. Lord have mercy. So we're just gonna, actually, you know what, let's just do it. Let's just do it here. So the height of this is obviously 5. The base of the triangle is obviously gonna be 8 meters. And they're both in meters, right? Now in this portion here, the area of a triangle again is gonna be 1/2 base times height. This is 1/2 times 8 times 5, right? Okay. This is 4 times 5, which is 20. So we know that the area of the triangle is 20 meters squared. Now, again, area of whole shape. So, and then we know that the area, now let's just look at the area of this part here, okay? So, we know that the area of the rectangle is going to be, sorry guys, hold on. I hate that. I don't know why it does that when I go on. Oops. I don't know why it does that when I put it on YouTube. It always does that. Where it like, it doesn't sync right with the, you know, with the live stream. Now, let's just move on. So here, we know that the area of the triangle is 20 meters squared, and the area of rectangle is going to be 3 times 8. So really, it's 3 times 8, which is 24 meters squared. 3 meters times 8 meters, 24 meters squared, right? So the area of total figure, or total shape, total area of shape, really. So the total area will be area of triangle plus area of rectangle, which is going to be 20 meters squared plus 24 meters squared, which is really 44 meters squared. And that is the area of the entire shape, right? Now, let's go ahead and move on. Does that make sense, guys? Does that make sense to everybody? I just want to make sure that it makes sense. Press 1 if it makes sense. Press 1 if it makes sense, guys. Like I said, if it doesn't, let me know. If y'all have any questions, let me know. So alright, so let's move on to the next one. Let's move on to the next one, okay. The area of, so this one actually involves kind of two, so it involves like two rectangles really. So I'm just gonna, this is number 5, I'm just gonna do this where, so where we actually, I'm gonna try and just draw out I'm gonna try my best to draw this out. Okay, good. Alright. Oh God, no. Okay. So, let's see here. Okay. Now, this next one, obviously, and actually one of the lines will be longer than the other. But we're just gonna try and, I'm gonna try my best to draw this out. It's a little hard to draw it out, so it's not gonna be drawn to scale, obviously. It's kind of difficult to do that. Something like this, right? And then we have this part here. Okay. It's just gonna look like that. I know it's kind of big. Let me try to see if I can shorten it a little bit. Kind of make it smaller. Don't want to make it so big either. Okay, I think that looks fine. Alright. Now, what we're given is so we're given the following, right? I don't know why it keeps doing that. Every single time I like put the OneNote, it's always doing that. Let me see if I can just, I want to see it from here. Okay. Alright, I don't know why it does that, but whatever. Sorry guys. So alright. Now what we're gonna do, and the side lengths of this, so we have this part as 10 meters. We have this part as 10 meters. We have this part as 10 meters. And then finally we have this entire part as 20 meters. Now, here's the thing, okay? Let's draw kind of this imaginary dashed line here. you can clearly see that these two are congruent. So this has to be 10 meters. And let's make this length over here x meters. Okay. Now, here, sorry. Now here, we're gonna, hopefully y'all can read that color. I really don't know. Hopefully y'all can. So what I want to say is that the length of the rectangle really, and actually I don't think we don't even need this actually. Never mind. Unless it asks you to solve for that length, right? Really what this means is that, yeah, we don't need this. We don't need this at all. Never mind. I'm making it more complicated than I need to. But really, we just want to know that this kind of has that composite shape right there. So we're dealing with two rectangles. We're dealing with one that kind of looks like this, that has a side length of 10 and 10, right? And then, so that's one part, right? And then the other part is that we're dealing with a rectangle that's like horizontal, with a long horizontal like width. And it's 20 meters on the bottom and 10 meters on the side. So we're dealing with this as well. So we're basically saying that the total area is this rectangle, right? So area of this, so the area of this plus the area, plus the area of this. So, so the area of this. And what is the area of this? Well, the area is going to be 10 times 10, which is 100 meters squared. Again, remember, it's 10 meters times 10 meters, which is 100 meters squared. Okay. Plus the area of this portion, which is 10 meters times 20 meters, which is 200 meters squared. So 100 meters squared plus 200 meters squared, which will be 300 meters squared. So that is the total area. Press 1 if that makes sense, or if it doesn't, let me know so I can explain it more thoroughly. Let me know, guys, if that makes sense or not, because I really want to make sure. Okay, good. Vinx_anime, does that make sense to you? Everybody that's watching, does that make sense? Press 1 in the chat, or press 2 if you have any questions. Or if you have any questions, just ask. Okay. Let's move on. Now, this next part, it's like, okay, so this next portion, this next question, right, is number 6. God. We have this, like, I'm just going to draw it like this. I know it's not drawn to scale, but there's this, and then there's like oh Lord, how do I do this? It's gonna go kind of like that, right? And instead of this being, it's going to be like dashed. So let me just, it looks kind of like a briefcase if you think about it, right? If I had the monitor, what is it? Plugged in, this would not be doing that, but apparently I can't, I don't know, it just doesn't sync with the stupid, live stream. I don't know why. Now what we're given is that this part here, they're saying that this portion here is 5 yards. And then they're saying that this is 12 yards and this is 16 yards. Now, let me rewrite that. There we go. Now, let's look at the half circle again, guys. This is a half circle. Again, it's not going to be drawn to scale. Oh my, I'm just gonna draw a full circle and just erase this part. And then they're saying that from the middle, they're saying this is 5 yards, meaning that I'm sorry, not the diameter, the radius is 5 yards. So the radius is 5 yards. Now here, what we are saying is, so the radius is 5 yards, and of course, like I said, it's not the middle of the circle. I can't, it's hard to draw it. Again, it's not drawn to scale. These shapes are not easy to draw. But let's see. Give me a second, guys. So really, this is half a circle. So the area is 1/2 pi r squared. This is 1/2 pi times, and the radius is 5, so 5 squared. Again, this is the radius, so it's going to go 25 pi over 2. Like I said, unless, I mean, you can just calculate it after. And so we know that it's this area plus the area of the rectangle. So area, total area, is equal to area of half circle plus area of rectangle. So, here, we're gonna, oops, we're gonna go ahead and just put all of this stuff in. So it's gonna go, so we know that the area of the circle, the area of half circle, sorry, is equal to 25 pi over 2. So this is this part. and then plus the area of the rectangle. The area of the rectangle is 16 times 12, so this part here is 16 times 12, which is 16 yards times 12 yards, which is really gonna be, what is it gonna be? $192 yards squared. And so again, it's going to be 25 pi over 2, and like I said, area of the rectangle is this part. So it's going to go 25 pi over 2 plus 192. And this is in yards squared. This is in yards squared. So if we calculate that, it's going to be approximately 192 point, I think they said round to 1 decimal place. Yeah. So 192 point, I'm sorry, 231.3 approximately. So the area of composite shape, the total area, is 231.27. I'm sorry, 0.3 yards squared. Okay, press 1 in the chat if that made sense, or if you have questions, let me know. Sorry guys, give me a second. There we go. Press 1 in the chat if that made sense. I'm trying to press, okay, there we go. Sorry guys. Let's go to the next one. There's only a few more, guys. There's only like 3 more that we have left. So number 7, there's only like 3 more, so I'm gonna end it soon. Number 7 gives us, now again, give me a second. It gives me something like this. And then, alright. Gives me something like this. Again, it's not drawn to scale. What I'm going to do is this. Excuse me. And then it gives me like this, sorry guys, hold on. Oh my goodness. Something like that. Okay. So, just trying to get it to the main, like how it looks on the diagram here. So they're telling us again that this is 5 centimeters, and then they're telling us that this side here is 10 centimeters. Again, guys, this is yet another example, just like number it's kind of like number 6, a little similar, except now we're dealing with a square and a half a circle. So but we're still doing the same formula because the area of a square is the same as the area of a rectangle. Okay. Now, we're almost done here, guys. So, so again, we have this going on, something like this, right? And we know that the radius, obviously, the radius is 5 centimeters, if I'm correct, yeah. So the radius is 5 centimeters, and then we're talking about half a circle. So we're just gonna go here. And so what this is gonna be, it's gonna be 1/2 pi r squared. So it's gonna go 1/2 pi times 5 squared, which again would be 25 pi over 2. But this time, so it's kind of like the last example, except this time we still get the same area for half the circle. But this time we're dealing with a square, so we know that all of these sides will be congruent, right? So this side will be congruent to this side. So what did I always say about the square, right? The area of a square, oh Lord, if I know that this is my base, the area is b squared. So I know that the area of square is area equals 10 squared, I think is what it said, yeah, which is 100 centimeters squared. Yes. Like I said, it's centimeters because centimeters times centimeters is centimeters. Oops. So let's just go ahead and let's go over here and so now let's go over here and add this to 25 pi over 2. So now the area of the total, so the total area of shape, of composite shape, is going to be area of half circle plus area of square. Which is going to be the following. So it's going to go 25 pi over 2 plus, so 25 pi over 2, which that was the area of half the circle, plus the area of the square, which was 100 centimeters squared. So then, if we do this in the calculator, right, Let's do this in the calculator. Oops. Sorry guys, give me a second. And again, it wants you to round it to 1 decimal place, so this is approximately 139.3 centimeters squared. So that is the total area of this shape. Press 1 if that makes sense, or if it doesn't, let me know what questions you have. All right. Now, let's go ahead and we have only a few more left. Number 8 and number 9. So, number 8, this is number 8 is again, it's like a square mixed with a triangle. It kind of looks like a doghouse if you think about it. So it's just gonna go like this, something like that. It's not drawn to scale, but y'all kind of understand the main idea. Of course, oh god, no. Of course, this part isn't drawn in, so you're gonna kind of have to, that's the thing with these, you're gonna have to draw certain parts out, so we can clearly see that we can make 2 different shapes out of this. You always want to make up your shapes, because you kind of have to be visual with this. Use your vision with this stuff. Now, what they're saying here, let me think for a second. So they're saying that this side is 12 feet, yes. And also this side. Obviously, this is a square, right? We have a square and a triangle. And then they're saying that this this side here, so they're like making this, they're doing this, and then they're just saying that this side here is 6 feet, right? So they're saying 6 feet here. I don't want to draw these 2 lines because I feel like that's going to confuse. But we can clearly see that that is going to be the height of the triangle up here. We can move this. Oh Lord, no. Like, we can clearly see that this is going to be right here. So we know that this is going to go here because it's the same kind of height, right? We can say that the height of the triangle is 6 feet. So we know that we have a triangle. And again, it's not drawn to scale, but we can clearly see that the height is 6 feet. Now the base is half the rectangle. Actually, I'm sorry. Or no, not half the square. It's the base is 12 feet. So the area of this shape here, this triangle, is going to be 1/2 times 12 times 6, which is 6 times 6, which is 36 feet squared. So we know that the area of this one is 36 feet squared. Now we want to find the area of this one and add them together. So the total area, hold on, is area of triangle plus area of square. So so again, area of triangle is 36. So that's 36 plus the area of the square is 12 times 12, which is 144. Y'all can clearly see that the area of this is 144 because base times height, length times width.